Here's problem 611. A race car traveling at 100 meters per second enters an unbanked turn of 400 meter radius. The coefficient of static friction between the tires and the track is 1.1. The track has both an inner and outer wall. Which statement is correct? Alright, let's imagine what's going around in this problem. We're going around a circle, which I'm showing from an angle, and here's our car, and here's the outer wall. And for us to negotiate this circle, we must have a centripetal force. And the centripetal force would be center seeking toward the center of the circle. And the value of that force, let's make this a vector up here, the value of that force would be mass velocity squared over r. And so we're going to be looking at mass times 100 squared over 400, and that is going to be equal to mass times 25. So in other words, the centripetal acceleration is 25 meters per second. Let's just write that down. Second squared, 25 meters per second squared. Well, the only force we have that can help us with that centripetal force is indeed the static frictional force. Static because we're hopefully not sliding outward in that direction, in the radial direction. So our static frictional force is the only thing we can rely on, and that's equal to mu times the normal force, which in this case would be mu times mg, because we're on a unbanked turn, flat turn. So that's going to be equal to mu 1.1 times the mass times 9.8, and that will be equal to the mass times 10.8. So the acceleration of that frictional force is 10.8. In other words, we want our net force to be equal to the centripetal force, and that's all being supplied by the frictional force. So we have that 25m is equal to maybe to the frictional force, which is 10.8 m. Nope. The frictional force cannot supply the force needed to negotiate this turn. It does not have enough to do it. And hence, we won't be able to negotiate in the circle, and we'll start to slide outward on this turn. So because 25 is greater than 10.8, the car will slide outward. There's no net centripetal force that will negotiate this curve, and hence it will indeed crash into the outer wall. So that will be the result in this case.